Here we take the given function as it is. That is f of x equals to 4 root 3x square plus 5x minus 2 root 3. Now to find the zeros, we assume f of x is equal to 0. So the quadratic equation becomes 4 root 3x square plus 5x minus 2 root 3 is equal to 0. Next, we need to factorize this expression. For that, we use the splitting the middle term. First, we take the first term and the last term. For that, 4 root 3 and minus 2 root 3. Multiplying these terms, that is 4 into minus 2 gives minus 8 and root 3 into root 3 gives 3. So the product becomes, that is minus 8 into 3 is minus 24. Now we look at the middle term, which is 5x. We need two numbers whose product is minus 24 and whose sum is plus 5. Those numbers are plus 8 and minus 3, because 8 minus 3 equals 5 and 8 into minus 3 equals minus 24. So we split the middle term. 5x becomes 8x minus 3x. Now the equation becomes 4 root 3x square plus 8x minus 3x minus 2 root 3. Next we group the terms. That is 4 root 3x square plus 8x minus 3x minus 2 root 3. From the first two terms, we take 4x as common. We get 4x into root 3x plus 2. From the next two terms, we take minus root 3 as common, so that we get root 3 into root 3x plus 2. Now, root 3x plus 2 is common in both the terms. So we take out the common term, the leftover is 4x minus root 3. So root 3x plus 2 and 4x minus root 3 are factors of the given quadratic equation. Next, we need to find the zeros. For that, set each factor is equal to 0. That is, root 3x plus 2 is equal to 0. Bringing this 2 to right side, we get minus 2. And bringing this root 3 to right side, it becomes divided by root 3. So, x is equal to minus 2 by root 3. And 4x minus root 3 is equal to 0. Bringing this minus root 3 to right side, we get plus root 3, and bringing this 4 to right side, we get divided by 4. So x is equal to root 3 divided by 4. These are the zeros of the given quadratic equation. The zeros are minus 2 by root 3 and root 3 divided by 4. Let us assume one zero as alpha and another as beta. Now we need to find the sum of zeros, that is alpha plus beta. Substituting the values of alpha and beta, we get minus 2 by root 3 plus root 3 by 4. Since these are fractions, we need to take LCM. The denominators are root 3 and 4 and they don't have a common factor. So we take the LCM as 4 into root 3. Now we do cross multiplication in the numerator. That is 4 into minus 2 gives minus 8 and root 3 into root 3 gives 3. So the numerator becomes minus 8 plus 3, which is minus 5. Therefore, the sum of zeros equals to minus 5 by 4 root 3. Next, we find the product of zeros, that is alpha into beta. Substituting this alpha and beta values, we get minus 2 by root 3 into root 3 by 4. Cancelling this root 3, we are left with minus 2 by 4. Simplifying this by 2, we get minus 1 by 2. Therefore, the product of zeros is minus 1 by 2. Next, we have to find out sum of zeros and the product of zeros from the quadratic equation itself. For this, we consider the given quadratic equation, that is f of x equal to 4 root 3 x square plus 5x minus 2 root 3. Comparing this equation with the general quadratic equation, that is f of x equal to a x square plus bx plus c, we get a, b and c values. A is equal to 4 root 3, b is equal to 5, c is equal to minus 2 root 3. Sum of zeros formula is minus b by a. Substituting this b and a values, we get 5 by 4 root 3. Minus is in the formula, so we get minus 5 by 4 root 3. Next, we have to find out product of zeros. The formula is C by A. Substituting the C and A values, we get minus 2 by root 3 divided by 4 by root 3. These root 3's are cancelled. And minus 2 by 4 simplification, we get minus 1 by 2. So, sum of zeros and product of zeros from the quadratic equation are equal to sum of zeros and product of zeros from the zeros of the quadratic equations are equal. So, the given quadratic equation is verified.